The second portion of this sample problem is looking at masonry. So we are going to calculate different types of masonry units given some changes to our Plan 100. So again, Plan 100 has a foundation system that is made out of concrete. So we're going to change it. We are now using a masonry foundation. Our side and rear walls are no longer 8-inch poured walls. They're going to be 10-inch thick CMU walls. Instead of having a beam pocket poured into our foundation wall, we're going to use 16 by 16 pilasters at both ends of our beams. We're going to require horizontal joint reinforcing every third course, which means it is every 24 inches, starting 8 inches from the footing. So essentially after the first course of block, that is where we're going to start our horizontal reinforcing. We have a bond beam or a lintel beam that runs the top course of the 10-inch walls only, and we have 64 cubic feet of mortar required to place 1000 CMU block. Doesn't matter, all types of block. So we have multiple problems. We actually have 6 through 29 that we're going to be calculating. So make sure you refer back for each problem as to which sample portion we're actually working on. Starting off, we're going to go back with our concept of center line. It's actually a little easier to demonstrate center line when you're working with masonry as opposed to concrete. So we have some masonry little blocks that we're going to be working with for some demonstration purposes. When we lay masonry, we lay it in a brick pattern, meaning that we're actually going to stagger it. Not all of our joints are going to be in line with one another, so we're staggering our joints. When we run the course that comes in 90s with our front wall, we then would have to stack on top of that. So if we continue both walls in both directions, what we can see then is when we lay this on end. So if we are looking at the side of it, and if we're counting the block that we have, we can easily count in our calculation that this end will count as a full block if we're just simply counting 1, 2, 3, 4, 5, 6. But since this actually connects the two rows together, we can see that if we count this block here, which we just did, if we're now counting on this side of our foundation wall, it's going to be counted again. It's going to be double counted. And that's our issue with centerline, and that's why we use it in our calculations. So another thing that we are going to look at with our CMU block is the dimensions of our block. So the standard face of any CMU block, if we look at it in a larger proportion, they are always going to be 16 inches in length, and they are always going to be 8 inches in height. This is actually our nominal dimensions. And what that means is it actually includes a thickness of mortar. So if we have a mortar joint between this block and the next, it includes a 3/8 inch mortar thickness. So the actual size of the CMU is 3/8 less than 16 inches and 3/8 inch less than 8 inches. So 16 inch and 5/8 and 7 inch and 5/8 are the actual dimensions. But we do all of our calculations based off the 16 by 8 because this is what we are looking at in terms of the vertical face of it. So if it includes that mortar joint thickness, it will actually save us some time when we are trying to do our calculations. From this, though, we can figure out what is called a CMU factor. CMU factor that can easily convert the square footage that we calculate, that is the face of our foundation, to a number, a count. If we're looking at our nominal dimensions, 16 by 8, 16 inches by 8 inches, we can see that that is 128 inches squared. If there are 12 inches in a foot and we square that, we can divide by 12 squared, or 144 inches squared per foot squared, and we will get 0.889 square feet. It's actually 0.8 repeating on and on and on. So this is 0.889 square feet for each CMU block. If we inverse this value, so to inverse, we simply take 1 divided by our 0.8 repeating, and we will come up with exactly 1.125 CMU per square feet. We can easily then convert any square footage that we calculate for any wall into a count for our CMU block by multiplying by this 1.125 CMU per square feet. As long as we have a standard block, that this will apply. If we're ever referring to our block and we call it an 8-inch block or a 10-inch block or a 12-inch block, the three ones that we're going to focus on in this sample problem, all of these numbers refer to the width, or you could also call it the depth of the block. If it is only one dimension that is going to be used, then it is talking about the depth, so the thickness of our wall. The face, again, will always be 16 by 8 when we're dealing with our CMU block. We're going to need that dimension as we calculate the square footage and then convert it into a number for our count of CMU block. So now that we have our CMU factor, we can get into our calculations and back to our centerline method for determining the square footage of our wall. So number 6 says calculate the centerline length of the front foundation wall. We learned about our centerline calculations when we're dealing with excavation. It is the same concept, but it is not the same number as before, because as this problem has stated, we're changing from 8-inch thick sidewalls to 10-inch thick sidewalls. So we start with our 36-foot overall length of our foundation, and again we subtract half of each of our sides, and in this case, because we have 10 inches not 8 inches, we're actually subtracting 5 for each one of those. 35 feet 2 inches is now the center line length for our foundation. Number 7 is looking at the center line length of the side foundation wall. So the width doesn't matter, either side will do. 26'4" is our overall dimension. We still have 12 inches for our front wall. That did not change, but again, our back changed to 10 inches. So that gives us 25 feet 5 inches for our side foundation walls. Number 8 is looking at the center line length for the back and side foundation walls. Essentially, we're looking for the center line for all 10-inch walls. So we have two sides at 25 feet 5 inches. Our back wall is 35 feet 2 inches. So 86 feet even is our back and sides center line dimension. And the last length or center line that we need is the center line for the entire foundation system. So we can do that by taking our back and sides that we just calculated and adding in the front wall. and that will give us 121 feet 2 inches. Or if you didn't want to use the number you just calculated and calculate perimeter the way you're used to doing perimeter, 2 times the length of 35.2 plus 2 times the width of 25.5 will give you the same answer as 121 2 inches. Or you can do it both and check your answer. They should come out the same, and that is acceptable. The reason why we are calculating different numbers is that we are going to use different numbers depending on what we're calculating. In quantity takeoff for estimating, we always want to keep it different or keep it separate if it is different. So when we're dealing with 12-inch walls versus our 10-inch walls, but there's sometimes where it doesn't matter the thickness of our walls, so we can use the whole foundation system. So if we go ahead and calculate each one of these numbers, we will have them available when we need them. So once we have our lengths, we can start looking at the square footage of our walls. And the important thing to know is that we're looking at the vertical square footage. So this is the face of the wall. We're no longer looking down on it as a plan view. We're looking at it as the face of the wall. So number 10 is looking at the square foot of 8-inch wall systems. Remember, when we're only given one number, this refers to the width. So we're looking at where could we possibly have 8-inch walls? Well, we have 10-inch back and side walls, and we have a 12-inch front wall. So at first glance, it appears that we don't have 8-inch walls anywhere. But if we recall, on our front wall, we have this brick ledge, 4 inches. If our overall wall is 12 inches, then that means, lo and behold, we have 8 inches for our first course of our top of the front wall. So we have just one course that is 8 inches thick. So it's the width that is referring to the type of block. So this is one situation where you could use the full length, since we know it runs across the full length of the front wall, but just to get into the mindset of using centerline, we'll just go ahead and use our centerline length that we calculated from number 6, 35 foot 2 inches, it's the length of the front wall. And here we multiply it by 8 inches, but be careful, because this 8 inches that we're referring to and what we're calculating is actually the 8-inch height, not the 8-inch thickness. So this is the 8-inch height. When we're dealing with an 8-inch block, it can get confusing because both the width and the height are the same, but when we're trying to find a vertical square foot, we need the height, not the thickness. So if we multiply that out, we come up with 23.4 repeating, or 23.4 square feet of 8-inch block. Number 11, we're looking at the square foot of 10-inch walls. So again, 10-inch is the width. We've determined that the back and the sides are all 10-inch block. We don't have a brick ledge, so we know it's going to be 10 inches all the way up. So based on our centerline length that we calculated in number 8, we can multiply that by the full height of our wall. We don't have to come down at all, so that's the wall height. If we look at our foundation plan, 668 square feet is our vertical square footage for our 10-inch walls. Moving on to the next page of our sample problem, looking at number 12, we are now looking at the square footage of our 12-inch walls. Again, the width. So we're talking about our front wall. We determined that the center line is 35 foot 2 inches. Be careful again here when we're calculating our height. We need to multiply it by the height of our wall, which is 8 feet. But don't forget, we have 8 inches because our top course is an 8-inch block. So we have one course that is 8 inches tall that happens to be 8-inch block. But regardless, we need to get rid of that when we're calculating the square footage of our 12-inch block. So we have 8 feet minus 8 inches, or 7 foot 4 inches, and that will give us 257.889, or roughly 258 square feet of our 12-inch block. If we ever want to know the square footage of our entire front foundation wall for calculation purposes, we're going to go ahead and add that together in our number 13. So this is the square footage of the front wall as it's labeled. It just says the square footage of the 12 and 8-inch wall systems. So we just take our previous two answers that we got, one from 2 problems ago and the one from last, are 23.444 plus the 257.889, and we get 281.3 repeating. So that's 281 roughly square feet. Again, you could calculate it slightly different way, taking the center line for the front foundation wall, multiply it by the full height. It will give you the same answer of 281.3 repeating. Either way that you calculate it is acceptable. So now that we have our square footage for each of our foundation walls, we can then figure out how many block using our CMU factor that we just figured out how to calculate. Once you have determined the CMU factor, 1.125, you do not need to show the calculation of that. You can just use that as a factor over and over. It's acceptable. So number 14 is looking at the number of 8-inch CMU required for the foundation system. So it doesn't matter the type of block, whether it's a corner block, stretcher block, we're all going to just use one CMU factor to figure out the total number. So we have 23.4 repeating as our square footage. We multiply that by our 1.125 CMU per square feet, and we get 26.375 CMU. It is not possible to have a decimal of a CMU. What that means is you'll need to make a cut in the field because it will not be the full length of a CMU, but you cannot purchase a partial CMU. So we always need to round up, and I will always use this symbol to mean round up to the nearest whole number. You can't use your standard rounding and round down because you'll be short material if you do that. So you need to round up, and that means we're going to have 27 CMU. We need a whole number for how many we are going to purchase. Number 15 is looking at our 10-inch walls, our 10-inch CMU. So that is our 688 square feet multiplied by our 1.125 CMU per square foot factor. This one comes out to 774. You can also use each as your unit. So if you want to write CMU to know exactly what you're working on, that's fine. If you want to write 27 8-inch CMU to be more specific, acceptable as well. Each is the generic unit for any counted item. So you can write 774 each, and that is acceptable. And number 16, we are looking at the total number of 12-inch CMU required for the foundation system. So that is our 257.889 0.889 square feet multiplied by 1.125 CMU per square feet, 290.125. No matter how small that decimal is, we need to round up to 291 CMU or each. So these numbers, again, are for all types of CMU, whether it's a corner block, key block, pilaster, all different types. So what the next portion of our sample problem will do, will cover how to figure out what different types of blocks we actually need to purchase. So if we're looking at number 17, we're looking at the number of 8-inch corner blocks required. So this is a corner block where it is finished on the end. A stretcher block actually has a place that is notched in on either side so that it can meet up with the next one and provide holes for adding grout and reinforcing. The corner block, though, is the finished end. As we know, for our 8-inch CMU, it is only the top course of our front wall. So front wall, we have one course, so essentially one line of 8-inch CMU. So we have 2 each is our answer, and that is simply we have 1 on each end. So we don't have to do any calculations to determine that. We can just say 1 on the left hand side, 1 on the right hand side. We have 2 as the number of corner CMU block. So for 18, we're looking at the number of stretcher blocks, so the remaining portion that are on the inside, and we determine that we have 27 8-inch CMU. This came from our answer in number 14. So if we have 27 total, 2 of them are corner blocks, then that simply means we have 25 regular stretcher 8-inch CMU. Those are the only 2 types of 8-inch CMU that we're using on our project. After that, we're looking at our different types of 10-inch CMU. So when we're looking at 10-inch CMU, we're looking at corner returns. This visual is posted on Blackboard to help you understand corner returns. We'll also be covering this in lab to see the different types. So we need to have the face of all of our walls be 16 inches, or half of that at 8 inches. If our wall thickness is 12 inches or 10 inches as it shows in our problem, we cannot have that be 8 inches. It will cause our stagger of our mortar joints to be off. So we have to do a corner return. Basically, a corner return is a special block that the overall thickness is whatever it needs to be to match the rest of the wall in this course. In this example, it is a 12-inch corner return, so 12-inch thick wall, but it notches in so that one end of it is that standard 8-inch, half of that 16-inch to allow our joints to stagger up. And then this is our first course. Our second course will then flip, and we will have the corner return on the other face so that we can ensure that the mortar joints on the other side also line up all the way up. So our corner return blocks are, as by definition, in the corners. Now, since on our front walls we have a 12-inch wall and the sides are 10-inch, we're actually going to be alternating between 12-inch corner returns and 10-inch corner returns. So the 10-inch corner returns will be in line with the 10-inch wall. The 12-inch corner returns will be in line with the 12-inch wall. This is where it's important to know your layout, to know whether you're going to start with a 10-inch corner return or a 12-inch corner return. You can actually calculate it either way. For purposes of this, we're going to say that we start the bottom course with a 10-inch corner return. So we'll say our bottom course has a 10-inch corner return where it meets our 12-inch wall. So we need to first figure out how many number of courses that we have in our foundation system. We have an 8-foot wall for our foundation, and 8 inches is 1 course. So the height of 1 course of block is 8 inches. If we take 8 feet divided by 8 inches, we see that we have 12 courses. So if we have a foundation, it's a rectangular foundation, we know that our back corner has a 10-inch wall meeting up with a 10-inch wall. Both sides are both back corners, but on our front walls we have our 10-inch meeting with our 12-inch. So 10-inch on this side, 12-inch on this side. So as our drawing had shown, if they are both going to be the same thickness, so in here it's an example of a 12, but it doesn't matter, it can also be a 10, we know that it is a 10-inch corner return for each corner or each course all the way up. So if 10 meets a 10 and we have 12 courses, that means this back corner will have 12 corner returns. This back corner will also have 12 corner returns. And on our front, we are going to have half of that. So they're alternating every other one. We have 12 courses, and if half of them are 10 inches, half are 12, that means we have 6 corner returns on this front corner. 12 over 2, we have 6 corner returns on the front left corner as well. So if we add them up, total back left, back right, front left, front right, we have total of 36 corner returns, 36 10-inch corner returns. The other type of special 10-inch block we have are the lintel blocks. The lintel blocks make up the bond beam that runs around the top course of our 10-inch wall. So top course of 10-inch wall only. There are 2 different ways that we can calculate this. We know we have 86 feet of 10-inch wall based on our center line for our back and our 2 sides. We can take our center line, that is the back and 2 sides, and multiply it by the 8-inch of 1 course high, so it's only the top course, and we can get a 57.33 repeating square feet of lintel block. Multiply that by our 1.125 CMU per square foot factor, and we get 64.5, which rounds up to 65 block. Or another way of looking at it is we have our 86 feet of 10-inch block in our center line. We can divide that by the width or length of 1 block. That will also get us the same 64.5, or round up to 65 number of block. But if you look back at your answer key, you'll find that that is not our final answer. And the reason being is because we cannot have our lintel block on our corners. We need to have our corner returns. We can make a corner return into a lintel or a bond beam, but we can't make a bond beam into a corner return as easily. So we have to take our 65 and subtract out our 2 back corners. And we will have that we have 63 of our lintel block. Moving on to our next problem. Number 21 is looking at our pilaster blocks. So our pilasters, if we're looking at our side walls, they are the blocks that are going to be holding up our beam that runs across the center. So they are stacked upon each other and they run up both sides of the beam. We have already determined that we have 12 courses running up our foundation wall. However, we have just determined in number 20 that we have a lintel block that is running around the top course. So if we subtract off the lintel, we have 11 courses of pilaster block. We have the pilaster blocks on both sides, so we have 11 courses on each side. Multiply by 2, that means we have 22 pilaster blocks total in our foundation system. For number 22, we have special keyed blocks that will go into our pilasters. So as we will see, they typically will look something along this line for our pilasters. This notch allows for a keyed block to come in and fit in and match up. This could either be a full block where it has our 2, or it will be a half block with just 1. And this will allow for the alternating up on our control joints or our mortar joints as we go up our foundation wall. You'll have both full blocks or both half blocks. Generally, you will not have a full on one side and a half on the other. This is just for demonstration purposes. We are going to calculate the number of keyed blocks we have. I have not specified between the half or full, so we're just going to calculate total how many we need. If we have 22 pilasters and we need 2 keyed blocks, 1 on each side for each pilaster, then we simply multiply that by 2 to have 44 key blocks. So now that we have calculated all of the specialty type of 10-inch block, we can figure out how many stretcher blocks we need. We do that in number 23. We determined back in number 15 that we need 774 total 10-inch CMU. We can subtract out the 36 corner returns that we have determined, the 63 lintel block, the 22 pilaster, and the 44 key blocks. Once we subtract all of those out, we come up with 609 of our stretcher block. The last 2 different type of block we're looking at both relate to our 12-inch. On our 12-inch, all we have are corner returns. So for number 24, we're looking at 12-inch corner return. Just like with our 10-inch corner return, every other course is going to be 12-inch corner return on our front wall. Now we determine that we're starting the bottom with 10-inch. So while we typically would have 12-inch corner returns every other one, or 6 at each corner, we have to take into account that the top course on our front wall is going to be our 8-inch block. So we will not have a 12-inch corner return there. So we only have, we have half of our 2 front walls. We would then show that we have 12, but we need to subtract off the 2 to account for the top course being the 8-inch block. So that leaves us with 10 corner returns for our 12-inch block. And that is our only specialty type block. So we can take our 291 CMU that we calculated in number 16 for our 12-inch block, subtract out the corner returns, and we are left with 281 for our stretcher block. Four problems left to calculate. The next one being a little difficult for some students to understand, and so there is another drawing on Blackboard that can help explain what we're meaning when we're talking about our horizontal joint reinforcing factor. So number 26 is looking at calculating this factor for the joint reinforcing on this project. We were given that the reinforcing is every third course. And since each course is 8 inches, 3 times 8 is 24 inches. Or you could also list it as 2 feet. We are going to define a 1-foot section. You can define it as anything you want, but it's very easy to multiply numbers by 1. So we're just simply going to define a 1-foot section. We multiply that 1 foot that we defined by the space between our horizontal reinforcing. So our 1 foot times our 2 foot gives us 2 square feet. So what this says is that for every 1 foot of defined space, we have 2 square feet. That accounts for our horizontal joint reinforcing. So that means we have 0.5 lineal feet of horizontal reinforcing for every square foot of wall when we reduce it down. There's another way of calculating it, and either way is acceptable. Whatever makes sense to you is the way you should do it. If we, instead of defining a 1 foot section, we look at 1 square foot of wall. And then we also need to use the distance in between our reinforcing, which is given as every third course, or again, every 24 inches or 2 feet. So you need to think what times our 2 foot of given spacing will equal the 1 square foot of wall we're looking at. You move your 2 feet over underneath your square feet. 1 square foot divided by 2 feet gives you 0.5 feet. So the same answer it applies is that you'll have 0.5 lineal feet for every 1 square foot of wall, or 0.5 lineal feet per square foot. Again, same answer. Either way that makes sense is the one you need to use. So in number 26, if we are looking at a 1 foot defined section times our 2 foot of given spacing, we again have 2 square feet. So our 1 foot divided by our 2 square feet means we have 0.5 lineal foot per square foot. So this is going to be our answer for number 26. We need to figure out how much reinforcing is needed on our 10-inch walls. So we need our square footage, the 688 square feet we've calculated before. We multiply that by our 0.5 lineal feet per square feet, and we end up with 344 lineal feet of 10-inch horizontal joint reinforcing. So the hardest part is figuring out what that reinforcing factor is, but once you have it, it is very easy to calculate how much you need. 28 is looking at your 12-inch reinforcing. This is the full front wall. So both the 12-inch and the 8-inch, we're going to just use the full front in our calculation. So that is the 281.3 repeating square feet times our 0.5 lineal foot per square foot, 140.6 repeating, so roughly 141 lineal feet. And finally, our last calculation is looking at the cubic feet of mortar required. So it is given in our specifications that there is 64 cubic feet for every 1,000 CMU. It does not matter whether it is 8-inch CMU or 12-inch CMU or 10-inch CMU. While there is going to be a little bit of difference between the 8-inch and the 12-inch, obviously, for the thickness of it, but the face and the sides are the standard. So for now, we're just going to leave it all as the same factor for each type. So we have 0.064 cubic feet per CMU. We multiply that by all the CMU we have. We have 27 8-inch, 774 10-inch, and 291 12-inch. We don't need to specify between the pilasters, the lintel blocks, corner returns, corner block. We can leave it all lumped together. And we get 69.888, or roughly 69.9 cubic feet of mortar required for this job. Again, refer to the plans on Blackboard to help you with these calculations, as well as the PowerPoints and the answers keys that are posted.